Welcome everyone, and thank you for attending today's webcast, Plant 3D Connections That Really Class Up a Joint. Our presenter today is Rick France. He is a solutions engineer with Hagerman & Company. We're also joined on the line by Brett Barkman. He is a solutions engineer with Hagerman & Company. He is on the line to help field questions as we go. Before we get started, I want to let you know that you're in listening only mode. If you think of questions during the presentation, you can type those in the question panel, which is located on the right-hand side of your screen. They'll be addressed at the end of the presentation in a Q&A session. And as we close down the session today, you'll be prompted to fill out a short survey. We ask that you take a few moments to fill that out for us. Once we started the webinar today, there were some technical glitches seeming to happen, so we're going to keep monitoring that as we go, but just to let you know that might be going on. Additionally, all registrants will receive a follow-up email tomorrow containing a link for the recording of this presentation. With that, I'm going to hand things over to Rick.
Well, hello. Don't know whether to say good morning or good afternoon. It depends, I guess, on where you're at. It's a good afternoon for myself. We're going to be talking about the pipe connection settings, and let's see, I do need to unpause my screen, so actually, let's see, let's show it now. All right, so I'm assuming everyone can see my screen at this point. And basically, we're going to be talking about what you see on my screen, which is in the project setup, the pipe connection settings here, which is divided up into two areas: joint setup up here, which also includes simple joints and compound joints, and then the second area is down here at the bottom where you have some additional settings that we'll touch on at the end. Mainly the only reason we're going to touch on these is because they're on the same screen, and I just want to do this screen complete in the end, all the way through. Now, the pipe connection settings is where the software is told how things connect up. So a flange to a flange, or threaded male to threaded female. So you can see this right here for a threaded joint. You can have a threaded female up to a threaded male, and also a plain end to a threaded female, things like that. And this is where you're telling it how these things are able to connect up. You may have noticed sometimes if you tried to put a class 300 flange connected up to a class 150 flange, they won't connect, and that's all controlled in these simple joints. Now, this is out of the box currently. There's nothing here that's on my screen that is not out of the box. But what we're going to be dealing with is creating new ones, because this doesn't cover everything in the world. So I'm going to go ahead and exit here for now. And you can see on my screen now that I've got this just a simple drawing, a flange and a pipe with a butterfly valve in the middle. And this particular butterfly valve happens to be a custom one, so I'm going to deal with it in my custom catalog, so I'm not affecting anything out of there. But it is set up just like the wafer valves out of the box. So if you came down here, you would see there's an N-type set up called WF on both N-type 1 and N-type 2. So it's set up exactly like the ones out of the box. So when you have a wafer connection, according to those joint end connections, that simple joint connection, it gets a set of bolts and a gasket. I'll come over here to my bill of material. You can see the same, this is on an ortho drawing. You can see here it's putting in 16 stud bolts and 2 gaskets. Now we're going to be using a wafer line. This particular valve that I have here is a lined valve that does not need gaskets. There's not an option for that out of the box. So I'm getting a gasket in my bill of material that I do not want. So that's the first thing. Also, being that this is a wafer valve, it should just have one stud bolt going all the way through from one side to the other, and right now it's giving me 16 of those bolts instead of just one set of 8 for the size of this valve. So that's the type of stuff I want to be able to fix. Now, initially we have to have what's called an encode that's available to be able to connect this up. And since I can't use the WF encode because that one out of the box already has gaskets, and if I remove the gasket and set this up on that one, any of the butterfly valves, for instance, that I put in that are wafer valves that are out of the box aren't going to work correctly because they possibly may need gaskets, because you can buy wafer valves both ways. So this is a unique situation where I need a whole new set of encodes and connections to make it work. So the first thing I need is an encode, and you do that by entering the command plant encodes. These are all the out-of-the-box encodes. Nothing's been added here at this point. And just to show you a few of the differences between them, if you look at the encode for plain end, if you notice, it's just the encode and then a description. When I go to modify it, you can see the encode and the description. And the plain end is set to be able to cut back, so that you can do cut back elbows and things like that. And without that checked, you wouldn't be able to do that. If I looked at a flange connection, the only difference is, besides the name and the encode, is this one's set to be flange-like. If I look at a threaded male, for instance, this one has no settings down here because it's not necessary. So you don't have to check anything, but you check the ones that apply to that particular end connection. When we look at the wafer valves out of the box, you can see it's just got the wafer-like checked. Now what the wafer-like check does is that puts in one bolt set, a single bolt set. So right there, I know there's something wrong with my bolt sets in the wafer connection, because it's adding a bolt set as well on top of the wafer-like one, but we'll talk about that later. And we're going to create a new one. So I'm going to come up here to add. I'm going to make it just like the wafer one here at this point, because the encode is going to be the same. It's just going to be a different encode for processing in the other part of the software. So I'm going to add one here. I'm going to call it WFL for wafer lined, and I'm going to give it a description of wafer lined, and it will be wafer like. Now again, checking this automatically puts the bolt set in for a wafer connection, so I don't need to add the bolt sets in the connection settings at this point, because the wafer like automatically puts in the one bolt set to go all the way through. I'll go ahead and say OK. You can see the new one down here at the bottom. Hit OK, and that's all I need to do to add the plant encode. The thing is, with this valve, it's already set to WF. Doesn't automatically change that. That setting for the valve itself is controlled in the catalog. So I need to be able to change that in my catalog to make this work. I found when you're dealing with encodes that it's best to, on catalog changes, it's best to close Plant 3D all the way. And I'm not even going to bother saving it or anything. There's no need to. But to close your Plant 3D, open up your spec editor, because we're going to be making a catalog change. And to me, this always seems to work a little bit better. I guess first I need to open up my spec. So I'm going to open up the spec from this project. I'm using the CS150 one. And once it's open, you can see it's opened up the entire spec. We'll go over here to the catalog. So I'm in my custom catalog down here. You can see right here is that particular wafer valve, and you can see it's set to a WF right there. So I'm going to select it, and all I have to do is change the end type. And since I added it to the software, it's down here at the bottom is the new one I just added. The thing to remember is this end type needs to be set on both ports. Now I could have easily just said all ports have the same properties before I set that and done it that way, but I wanted to make sure you saw that both ports, which is both ends of it, this is one port here, this is one port here on each side. So they both have to be set to this WFL encode that I just created. And it's only there because I created it. If I would have opened up this catalog before I created it, it would not have been there. So now that it's there, I've set these two. I'm going to go ahead and hit Save the Catalog. You can see in my catalog down here for the end type, it has changed. So now we got to go over here to the spec. and I need to move this out of my way from the meeting here. And okay, so here's that 8 to 12 inch butterfly valve we're dealing with. If I open it up in my spec, it still has WF for an N type because it's not going to update my spec just because I changed it in the catalog. So I'm going to need to remove this from my spec and add it back in. Before I do that, I'm going to come down here for the material code and copy that to my clipboard. Then we'll cancel and come over here and remove it from the spec. I'm going to apply the material of carbon steel and the material code I just attached to it. So I'm going to do the property overrides here when I put this in my spec. And right here is that item in my catalog. We'll add it to the spec, and now the one in my spec is the one with the N type of WFL. So basically, got to create the N code, got to make sure your catalog piece has the correct N code, then you got to make sure your spec has the correct piece with the correct N code. So we'll go ahead and save our spec and close out the spec editor, and I'll open Plant 3D back up. So everything has to shake hands. You can't just do one thing and expect it to fix everything. You got to make sure everything is shaking hands all the way through the product. So that was all just the preliminary stuff to get to where we can set up the joint connections. But what I want to show you is just setting up that doesn't fix the one here that's in my drawing. That one, well, properties palette. That one still has the WF N type because it was created from the old one. So I'm going to have to delete that one and get it out of my drawing. And to show you that this one is still not completely working, you can see the WFL is now on my butterfly valve here for my N code. But if I try to connect it up here, I'm going to get this message that it cannot connect the parts because there's not a connection defined for WFL to FL. So wafer line to flange. So let me go ahead and remove that, and let's go fix that. We do that, do the project setup. And once we get in here, we go to the piping connection settings, and we're going to start with a simple joint here. So you can see here, if I look at the wafer one that's already there and modify it, you can see they've given it the name, and it's got for end one, it's got the wafer, and for end two, it's connecting up to another wafer. So they only have this one going wafer to wafer. But here you can see here on wafer flange, they got this one going from a flange or a lined flange. I think those are the only two there. Yep, connecting up to a wafer. So we want to do something similar, but as you can see, these are all going to put gaskets in. So we need a whole new one that doesn't put a gasket in. So we're going to come up here to add. I'm going to call this one wafer lined. No spaces in the joint name, but the display name can have the space. So you've got to give it a unique joint name, no spaces or special characters, and the display name can be whatever you want it to be. And that's what you'll actually see here is the display name. Right here, you make a decision, is this going to connect up to imperial and metric components? In other words, if I check that box, if I've got a 12-inch wafer line flange or a valve connecting up to a 300 millimeter flange, it will let me do that as long as I have this as checked. If I'm not dealing with metric, there's no reason to do that. So I'm not dealing with metric, so I'm going to leave that turned off. Down here, we set what end one is going to be for the connection settings. I'm going to do similar to this one, but I'm going to include both the flange, the lined flange. Come down here, and there's my wafer valve, and there's my WFL. Because what I want is to be able to connect this up to another flange of any type, or another wafer connection, or another wafer line connection. So I want it to be able to connect to all four, so that's why I checked all four. Don't want to make it set up the plain end pipe right here. This is connecting to other types of flanges where I'm going to have bolts and stuff like that. On the N2, that one just needs to be set to the wafer lined. So I did it very similar to this one. I just added the wafer and the wafer lined in it and did the wafer right there. So that sets up my end connection so that they'll connect up. Right here are the property requirements. You may notice when you try to connect up 150 to 300 pressure class, it will tell you no. Well, that's because it's set up here in the pressure in the property class in every single one of these connections that are here out of the box. This is where I can tell it, don't connect up a 6-inch to an 8-inch or raised face to flat face. I'm going to set this one up exactly like the other flanges and the wafer valves that are already here. So I'm going to add a property. The first one I'm going to do is nominal diameter because I want to make sure 6-inch to 6-inch, 8-inch to 8-inch, all those are going to be required for it to connect. I'm going to add another property for pressure class. There's where I'm controlling 150 pound to 150 pound, 300 to 300, no 150 to 600. So I'm controlling that right there. The third one I'm going to do is facing, and that's where I control raised face to raised face, flat face to flat face, and things like that. Now we're going to take this one step that I probably wouldn't do in real life, and that's to show you how the matching values works. So I'm going to use matching values on the facing and go ahead and override it until you can connect a flat face to a raised face to any kind of joint that has a WFL in type. So I'm going to hit matching values, and all I'm simply going to do is place in raised faced, comma, flat face. By doing that, I can connect to my wafer lined valve a flat face or a raised face flange. So that's kind of a matching value override. So here you could actually set up matching values for pressure class if you wanted 150 to connect to 3,000. I'm just making something up, 3,000 pound schedule or something. You could set all that up. So that would be where you could do an override if you needed to. Now in this case, I don't need a bolt set because I did it as a wafer-like in connection, so it will get a bolt set. That's what shouldn't be done here in my opinion. It should not have a bolt set. That's why I had 16 bolts going through it. But here is also, I don't need a gasket, so I don't really need any fasteners in this case, so I'm going to leave these all blank. Now we'll come back and deal with this at a later point on how that works, but I'm just going to leave the fasteners blank because I don't need them. And I'll hit add. That added my wafer lined connection settings right here. So let's go test it out. We'll hit OK. Before it wouldn't let me put a valve on a flange here, but also I want to show you one other thing. That's a raised face flange. I'm going to come up here first and find my flanges. My computer acted a little funny there. And here's a flat face flange. If I try to connect that flat face flange up to the raised face, it doesn't work because the properties mismatch. That's where we added those properties, and flanges are set up to where the nominal diameter has to match. That would have automatically matched. Pressure class matches. It was totally the facing, raised face to flat face, that I got that message. I'm going to go ahead and remove it. And let's put our butterfly valve back in there. It connects up to the flange, no problem. There it is connected. At this time, you'll notice I do not have a bolt set. That's because it needs the other flange to put the wafer bolt set on there. And to show you how that matching value works, I'll put the flat face flange. That is a raised face settings on that particular wafer valve, butterfly valve, and it let me attach a flat face to it. So now you can see single bolt set there. Everything's working correctly. Now I really don't need those. I'm going to deal with the one in the middle. So I'm going to go ahead and erase those. And let's put one right in the middle of the pipe. Now I'm getting the error again. The reason I'm getting the error this time is I'm trying to connect a wafer lined up to a plane, and we didn't define plane in there. But what you got to think about is when you're connecting a valve in a pipe there, like a flanged valve or something, it actually puts the valve in there and then puts the mating flanges. So this is called a compound joint. So the simple joint's working where I'm connecting it up to the flange, but the compound joint is not working where I'm connecting it on a piece of pipe. So let's go ahead and get that out of here, and let's go back to our project setup. Compound joints are controlled down here. Now I could just as easy create a whole new compound joint for this one, but in this particular case, the auto flange joint is perfectly fine. It just needs to know that I want to be able to use this to connect the WFL connection to a beveled or plain end or universal. So I'm going to modify this one instead of adding it. But if I was to hit add, I would get this same screen. I just have to define a joint name and display name. In this screen, it's just the same as the other one. Do you want to connect to imperials? In this case, I don't. You can see on the end one, it's got flange, lug, WF defined. I'm going to add WFL to it. Over here on end 2, I'm not going to make any changes, but that's where it's got the bevel, the plain end, and the universal joints right there. Now this middle part for connection component, if this was add, I would need to come in here and select add and tell it that I'm connecting a flange, and then I need to tell it the end type, the facings, and the nominal diameter and things like that. But that's where I would set up how it's going to connect those mating flanges between these two connections. So that's why it's a compound joint, is because you're not just connecting the wafer to the plain end, you're putting flanges in between it. So that's where it's going to add that. So I'm going to hit modify. I've added WFL to it. Just to save a little time, I can come up here to mixed auto flange joint and modify it, and you can see it's all the same settings. The only difference is this one has the imperial part of it, and I can add the WFL to it here, and I don't have to have the connection up in the simple joints to include the imperial. I can do it here, and it's only going to do it on the compound joints, but I could go ahead and do that at the same time. That sets up the compound joint. Let's go try it out. Hit OK. The first thing I want to do is grab my valve here. We'll place it in the middle of the pipe. Hit enter. Everything connected up with no questions. And if you look down here, only the one set of bolt set is there. And let's see, that's pretty much all I need for this one. So let's hit save, and let's go see how it changed our bill of material. So here on my bill of material, the first thing I need to do is update my view since I changed the valve out. That automatically updated my bill of material. I'm going to type in my little routine here to get my bill of material where it looks nice. And you can see here it's putting in 8 bolts, and they're stud bolts. So I've got 8 bolts going right through this all the way, and no gasket, which is exactly what I wanted. So in this particular situation, I've taken it as far as I need to. But that's how those connections work. Now, you may have noticed that when I did my update of the bill of materials, and everybody's probably used to this, to where you see it messes up everything. I'm actually going to put in a new bill of material so you get the one out of the box. I'll just place it right here for now. So it's basically got ID, quantity, nominal diameter, material code, and it just doesn't look real good, and most people want to do a little cleanup. I've got a little command I'm running here for bill of materials that basically formats that for me. It's a working bill of material. Still, I can go to BOM annotation and tell it to annotate right off of it just like I normally would, but it's got a built-in format to where I don't have to lose that. And the only reason I'm telling you this is because I knew somebody eventually would notice that I'm doing something here. This is a little routine I wrote. Basically, you can go to a bill of material setup, and you can set up how wide you want your columns. Notice I renamed my columns from ID and ND and material code, so I can set the names of the columns. I can set the widths and how it's going to be. For instance, if you notice the weight, if I come over here and change it to text to show you what it looks like out of the box, we're getting 109.6519 there. But in here I can actually tell it, I want this to be a number, and I want it to be decimal, and I want a precision of 0. And I'm controlling row height and everything. The reason I'm showing you this is we have what's called the hub. This is our little advertisement here. You went to Hagerman.com. You'll see a link on the Hagerman website called the hub. This routine is going to be available on the hub for free in about 2 weeks. So it'll be up there, and you can download it. And I've got to make an instructional video of how to install it and how to use it and set it up and stuff. But basically, the hub is for Hagerman customers who are on subscription. So you have to be a Hagerman customer to get to it. You have to be on subscription. If you meet those qualifications, you can. If you're not already a member, you can set up a username and everything to where you can log on here. And look for it in about 2 weeks. It should be on the hub there, and you can download it and use it as is. Once you get that downloaded, again, you have to be a Hagerman customer and you have to be on subscription, but that will be available for all those users at that time. In the meantime, though, that's basically got a little demo of what it does when you're looking at it. But let's take this one more step further with the connections. This particular valve, wafer valve, is going to need lug bolts, not stud bolts. So it's got the wrong kind of bolts in there. So I should have 16 lug bolts going in on each side, not 8 stud bolts. So I want to fix that. Let me show you how you do that. We'll go back to our project setup in the simple joint. Right here, find our WFL one, and we'll modify it. All right, so this is where the fasteners can be used on this, to where I want to tell it to use lug bolts instead. So I'm actually going to include a bolt set in this case. So I'm going to tell it bolt set. I want to set it to where it knows to use lug bolts by default, and I do that via the spec filter. So with bolt sets connected, I'm going to select the spec filter. You've got all different things you can set up here for how you want it to work and all, but right here you'll see is lug set. And this is basically where you just tell it to use lug bolts instead. So I'm going to check that box. I'm going to set the value to 1, which means yes, true, this is using a lug set. So I'll hit OK. Now I've got it set the way I want because I still don't want a gasket since it's lined. We'll hit modify, hit OK. Again, doesn't update existing ones, so I'm going to need to delete this one, place a new one. What you'll notice now is instead of 1 bolt set, I've got 2 for the lugs, which is actually not true either. You'll see that in a minute. Right here, I'm going to go ahead and update my view. I forgot to save the drawing. Let's get it the same reformatted. All right, so now you can see I've got 16 lug bolts, but I also have 8 stud bolts. What you couldn't see there was a bolt set on top of the bolt set. So there's actually 3 in that drawing. I just couldn't see it, nor could I select them separately. But I have actually 8 stud bolts that I didn't mean to have because I just wanted the 16 lug bolts. The reason being is, back in the plant end codes for WFL, hit modify. We told it right here to use 1 bolt set, and then in the project setup we told it to use lug set. So basically we told it to use 3 bolt sets for this particular valve. So in this instance, if I just want the lug bolts, I need to turn off the wafer like. Now when I turn that off, hit OK. Once again, delete it. Add the butterfly valve. I still see the 2 bolt sets, but there's not one on top of each other at this time. This time I'll remember to hit save. We'll update the view, update my bill of material format, and now I have 16 lug bolts, exactly what I wanted. So you can see these have to shake hands. The encodes have to shake hands with the catalog, which shakes hands with the spec, which shakes hands in here with the pipe joint connection. So there's several different areas of the software that were in play with these plant encodes and connections. This also works, made the change to my isometric. If I was to create an isometric, I'll let one get started here. This is such a simple drawing, it'll only take a few seconds. But my bill of material, I was just using the ortho one because it's quick and easy to be able to just update it and see the change, where in an isometric it takes a few seconds for everything to process. It has processed at this point though, and you can see here bill of material in my isometric is exactly the same. 16, got the bolt set for the lug bolts, no gasket. So everything's working all the way through the software with the setup that we have here with those plant end connections. And you can make as many as you need. You can make as many plant encodes that you need. You can make as many joint setups as you need, as many compounds to accomplish what you need to accomplish in the project. That pretty much sums up the joint connections for simple and compound. We have 4 other settings here I want to touch on because they're on the same screen down here. The pipe segments, weld gaps, weld dots, and wafer bolts. So let me show you how these work. Minimum length out of the box is set to 1. That means 1-inch piece of pipe is as small as you can draw. You can set the minimum length for a piece of pipe as low as a 1/4 inch and as high as 18 inches. So for instance, if I tried to go higher than 18 inches, it's going to give me a message of it's got to be at least 18 at the most. I'm going to set it for 12, which that means longest piece of pipe, shortest piece of pipe I can draw is 12 inches. I'm just oversizing stuff so you can actually see it at work here in a second. The weld gaps affects cut lengths, but basically if you wanted to use weld gaps, it will show a gap between the pipe and the joint. Like I'm going to draw a pipe with an elbow. So that welding point between the pipe and the elbow, there'll be a gap if I turn it on. Now the weld gap size can be set anywhere from 0 to a 1/2 inch maximum. So 0 minimum, 1/2 inch maximum, so that you can actually see it. I'm going to set it to a 1/2 inch so it's easily to be able to be viewed on my screen, and you can see what's happening there. And then the weld dots is the dot for the welds that goes where that weld happens between that pipe and the fitting. That can be set anywhere from 0 inches to 2 inches. So I'm going to go ahead and do the maximum of 2 inches so that you get a nice view of what it's actually doing. The last one is the wafer bolts. My personal opinion is I wish they would take the wafer bolts out of here because it does nothing. This is basically null and void today. Back in 2013, they made a change to the way the bolt lengths were calculated. 2012 and earlier, this came into play. They just you had a bolt length that was defined, and for a wafer bolt, you could tell it here to make it certain length longer by using this. From 2013 on, once they changed the bolt length calculation to where it now uses what's called bolt length mapping in the catalog, you have to set that in the catalog, like I said, under bolt length mapping. Not something we're going to show right now because that would be a whole another hour of a webinar. So we're not going to do that. So currently, if you change wafer bolts here, it does nothing. No matter what you change it to, no matter what you do. And it's kind of frustrating for people because they start making set changes here and trying to look for it, and they can't see anything changing, and that's because it doesn't work. Autodesk is aware of that. They have confirmed with me because I asked them a while back, does this do anything at all anymore? And they've confirmed that this is null and void. So this one you can ignore. It's null and void. Hopefully they will remove it at some point, but since 2013 through 2020, they have yet to remove it, so don't bank on it anytime soon. The only three here that are valid is the pipe segment, the weld gaps, and the weld dots. So I've maximized everything. I didn't maximize the pipe length, but you get the idea. I upped it quite a bit from 1 to 12, and we maximized everything else. Let's go ahead and hit OK and show you what those actually do. So I'm going to take a 12-inch piece of pipe up here and route it. If I start drawing it, if I try to draw a 3-inch piece of pipe, no pipe. 6-inch, no pipe. 12-inch, now I drew a piece of pipe. So it's got a 12-inch minimum, and I can control that, like I said, from a 1/4 inch all the way up to, I'm not sure if there's a maximum. Yeah, there's an 18-inch maximum. I slipped my mind, but anywhere from a 1/4 inch to 18-inch for a minimum length of pipe. I'm going to go ahead and make the turn. Just pick a point here and hit enter. Let me get my view cube back on there, which disappeared for some reason. We'll go to a top view, and here you can see the 1/2-inch weld gap. So right there, there's the 1/2-inch weld gap. It affects cut lengths because obviously, in this case, it's 12 inches because that's what I drew it. So if I was to do a dimension from this node to this node, for instance, it's going to be 12 inches. That's a 12-inch elbow, so that would be 18 inches for that length plus a 1/2 inch. So that is 3 foot, excuse me, 18, 12, 30 inches. My brain's not working right. Yeah, 30 inches and plus a 1/2 inch. So 2 foot, 6 inches and a 1/2 inch. So let's do a distance real quick from that node to this node. If I look down here at the X, it is 2 foot 6.5 inches. So if I needed it to be 2 foot 6, I would move it down. This would become 11.5 inches instead of 12 inches on its cut length. So it's affecting the cut length, but I can physically see the weld gap there of the 1/2 inch that I drew or set it to. The weld dots are these little dots that you see in the middle here. Now I'm going to change it to X-rays so it'll show up a little bit better. And we'll go ahead and go back to this view here. So there's a little dot which you can't see right now in there. And I had set it to 2 inches, so why can't I see it? Well, there's another variable that comes into play here called plant weld display. So I'm going to turn it is turned off by default. Well, plant weld display, as you can see, is off. I'm going to turn it on. Then I'm going to have to do a regen 3 for regeneration 3D. And there's my weld dot, which is set to 2 inches. So you have to have the plant weld display in to see it, but it's just the size of that particular dot wherever there is a connection, and that will show up in any connection. You can see it's over here in the wafered one at these flanges and at the bolt, right where the bolt set was. It's got those same connectors. So it affects not just welds, but connectors like flanges or for gaskets and bolt sets and stuff like that. But that's what the weld dot does. So that's pretty much everything about the plant setup here between for this pipe connection settings. We pretty much went over everything. I know it may have been a little fast. I didn't mean for it to, but we started a little late and I didn't want to go too late. Hopefully though, if you watch the video, you can pause it and get all the settings that you need to out of this. But just give you a couple of things here real quick before we move on. And take a look at any questions there might be. Right now, I just want to let you know that there are some Plant 3D training classes coming up. We have an advanced class coming up in just a few weeks, but new user and advanced again in November and December for Plant 3D. And on the P&ID side, we have the quick start and the advanced class coming up in October and December. So if you're interested in training, those are some upcoming classes that we do have on the books that you can register for. So I am going to turn this back over to Ashley to let her close us up here.
Thank you, Rick. And thank you everyone for attending today. If you think of additional questions, you can simply reply to that confirmation or reminder email that you receive from GoToWebinar, and we can get those to Rick or your sales rep to get those answered for you. Once again, if you could take a few moments to fill out the short survey, we would appreciate it. It will just pop up as we close down today. Thanks for attending the webcast, and have a great day, everybody.